we'll get ready. Today's lesson, we'll kick through all of it, and you'll have an assignment, which is out of the book, but we'll use up most of the class, so you really won't be working on it in class. And yeah, there you go. All right.
Are we getting this as paper copy?
Oh my goodness, Annie, yes.
Okay.
You are. I'm giving you a hard copy of the notes today. I know, it's so nice of me. All right, weekends. Weekends. Alex, what'd you do? Fun, quick, now.
Well, I just went to a track meet down in Louisville.
Oh.
Found out I'm slightly allergic to hops and beer.
Wow, okay.
I went to Scene 75.
Scene 75?
Yeah.
Very nice.
Lucky.
Is it like a reduced number of people there, or
What?
do they have like a reduced number of people they allow in?
It didn't seem like it because the whole parking lot was filled Friday night. So,
And you were able to go in?
Yeah.
Like they, okay, cool.
And then I was like my friend's birthday Saturday.
Friend's birthday, cool.
We did laser tag.
Cool. Ooh, laser tag, cool. Lane,
Just watch some baseball.
watch some baseball. Chloe.
I don't think I did anything. I slept, which was good because I haven't been sleeping.
You slept. That's good
Yeah.
for you, actually. Sleeping's good. Timbo.
My mom started watching Marvel movies in like chronological order.
So what's the first one?
Captain America.
So how far are you into this now?
We just watched the first Thor movie.
Cool. Rachel.
Nothing. I did not.
Grounded again.
No.
Yes. Your dad told me you were grounded.
I've actually never been grounded before. Knock on wood.
Say what?
No, okay.
Has Kate?
No, and the reason why is that's
You're-
not really an adequate punishment for either of us because we don't do anything. We don't have any friends.
Have you ever been like sent to your room where you can't leave your room, even like for a night?
No, my parents know that. I mean,
You'd walk out of your room if you were sent there?
I don't really.
Or have you ever been
They
made?
take my phone.
That's the punishment for you is not grounded. It's take away the phone. Well, that's a big one. So you lost your phone this weekend?
No,
They didn't take your phone away from you?
I didn't do anything.
I'm gonna say your dad. I'm gonna make you get in trouble now. I'm gonna just start telling lies to your dad. I'm gonna say you're Rachel's rude, man. She
Yes.
cusses in class and just all kinds of things you wouldn't believe. Where'd she hear all this stuff?
Her dad.
Yeah, exactly.
Probably.
What are you saying at home? All right. You didn't do anything really.
No, not really.
Take the dog for a walk.
Me and my mom, my sister went to Target.
Oh, there you go.
Did you get Starbucks while you were there?
What?
Starbucks while you were there? Didn't get anything while you were. Did you get anything?
No.
Who bought? What were you shopping for?
I don't know. When you go to Target, you never know what you want.
That is true, but usually you leave with something too.
Well, I don't know.
Because you see something, you go, I can't live without that when you really could.
I think my sister like got leggings or something. I don't know.
Okay. All right, Rachel, I'll let you up the hook here. Hey, Inkman, what's going on? What'd you do? Little tattoo work this weekend?
I wish.
Grounded. Got it. Just kidding you, Donnie. Donnie Donovan. That's your new name. Donnie Donovan. Donnie Donovan, Inkman. Annie Pacena.
You won't turn me in if I tell you this, would you?
You hit another animal.
I experienced my first hit and run this weekend.
What?
Do it.
Okay, listen.
Wait a second.
Listen.
I don't know if I want to hear this.
No, it's not.
First of all, this is supposed to be, what did you do fun this weekend? I experienced my first hit and run. Yes!
Listen, okay, me and three of my friends went to Bill's Donut parking lot. And I was asking my friend, like, if she knew what we were getting. And she's like, yeah, I got it. She goes to swing her door open. And when she swung open, it, like, hit the other car. Not a little thing, but like, it was a whole thud. So then she goes inside and comes running back out because the line was too long. And it looks like someone took chalk and just, like, drew it on the door. So we left. I mean, that was my weekend this weekend.
My car has that. I'm just kidding.
That's that exact same mark.
What was that?
You drive a truck or a car?
Car?
I thought you drove a truck. You seem like someone that would drive a truck.
I don't know.
Like a
No,
big
not
Dodge
now. I have a
Ram.
car. I used to have a big SUV, but I don't anymore.
Oh,
So, but no, I like a pickup truck when I retire. It's not functional for a family. It's not functional for a family, but that's okay. They're fun to have.
They are.
But anyway, so you guys hit and run. That's great. I won't be telling anybody that it was you. Okay.
What? Wait, what?
I'm glad that was fun for you this weekend.
Yeah, it was. Nothing else exciting.
Glad
happened.
that's fun when things get destroyed right here. Okay, I understand this. I see how it works.
I mean,
Yeah, it was really fun. I hit somebody's dog this weekend.
someone's okay. I would never. If I had a dog, I'd be crying right now.
Okay. All right. Well, that's good to hear. That's good.
Okay, don't.
I have a heart, okay?
I know you have
It's
a
just
heart.
present in certain places.
Okay.
That
Gotcha.
is not my mom.
Okay. Yeah, Bill's Donuts. I mean, that's whatever happens at Bill's Donuts stays at Bill's Donuts. That's kind of the rule. All right. Hey. Booyah! Abby.
I just worked the whole weekend and I saw
What was he doing?
laser tag.
He was doing laser tag.
Yeah.
What was his name?
I don't know. I wasn't.
What was your laser tag name?
I just joined.
What? Eclipse?
Yeah.
Eclipse. Okay.
That's the worst one.
Yeah.
You don't get to choose, do you?
But you can.
It depends, but I wasn't paying attention. I just grabbed the best and then
Oh,
he grabbed it and went.
Oh, man. All righty. Okay.
My aunt got a little puppy, so we met him. He's a little wiener dog, and he was like 4 pounds. He was so small.
What's his name?
Elliot.
Elliot the wiener dog? Oh.
He was really
That's
small.
so cute.
Black and tan, or is he
Bring
more
him
of
in.
a... is he-
Yes, bring him in, sneak him in.
I can show you.
Yeah, I want to see a picture of Elliot the wiener dog. I have to start putting him in word problems now. I got to write this down. Note to myself. Note to self. Include Elliot the wiener dog. Oh my gosh. Oh, he's spotted like that's cool. Elliot's cool. Elliot the wiener dog. Perfect. That's story problem material. You gonna steal him?
Yes.
Now you want one, don't you?
Yeah, they was really cute.
I'll bet. But you have dogs already, so
Yeah, big
Okay.
dogs.
big dogs. Savannah na na na.
I started watching White Collar.
White collar. I don't know what that is. Is that like is that a Netflix or is it a?
It's a USA TV show.
So it's on TV. Okay. Is it good?
I think so.
What is like white collar? It has to do with like somebody that has a white collar job, or no? Nothing about that at all.
I think so.
Okay. All right. Cool.
I found my pins at the
Got it.
store.
What's wrong?
I lost my pins a week ago and I just found them.
And they weren't lost.
This is a
They
happy
were in your
day.
book bag.
Happy day. Did he just say
Spring break. Who's going away for spring break? Anybody going away? Anything?
something crazy?
Nobody in this room going for spring break?
Staycation.
I'm going to say
You're not going to Canada yet. Roll here's going away for spring break? You don't know yet? Okay. Anybody in this room going anywhere for spring break?
I'm going to Centerville.
Going to Bill's? Get some more cars?
I was gonna try to rent a hotel room out with some friends, but you have to tell me when now.
At Bill's? Yeah.
Yeah, totally.
Going over for spring break? Spring break? Virginia?
Well, you have to be 21 now.
Colorado. All right.
That's okay.
So we're gonna get through this, guys. So for me, here, just so you know, you have 2 slides per piece of paper. So like this is the first slide you'll see in a second. So I just kind of have that set up for you. We're gonna get through all of this today. You'll be doing work on here. You can write things on here. You got to ask questions about things in here. So today you can see we're going to talk about arithmetic and geometric sequences and series. Okay. So before we even start talking about those, and Yusef, all this stuff is online as packet as if you can find it.
Okay, I
See it there. So let me put it up on the board. How many of you even know what a sequence is? You know what a sequence is? It doesn't have to be arithmetic or geometric. Like what in general is just a sequence?
Like you have a sequence hello,
Oh, that's true. You could have sequences like shiny material. Yeah, that's true.
or like alternating.
Alternating colors. Yeah. Okay. So sequence. Anything else? Anybody else know anything about the sequence? That's not what I want. Yeah, we're gonna say
Isn't it like a pattern that's like you can identify?
like a pattern you can identify. Yes, sometimes there is a pattern you can identify. Okay. Is a sequence always numbers? Doesn't have to be. Okay? Doesn't have to be. Does order matter? Yes, order does matter on a sequence. Okay, so so usually, what is going on with that? Hold on a second here. Get this thing over here. Okay. I'm just sorry, guys. Hold on a second here. I'm trying to. Why is that showing up on my? I don't want that up there. Perfect. So usually a sequence, it's a list. And for us, usually it's a list of numbers. It does not have to be numbers, though. It could be letters. It could be shapes. But it's a list, and it's a list that is in some type of order that matters. If you rearrange it, then it's changed. It's no longer the same sequence, okay? So you can have finite or infinite. Finite means that it's a set amount. It stops and ends. Infinite means it goes forever and ever and ever, all right? So those are the two different types of sequences, finite and infinite. We're talking about two specialized ones, arithmetic and geometric. So we got sequences, and we'll talk about what series are in a second. Let me get the lights here. We're going to get going. Woo! So this would be a sequence. Here we go. I'm just going to write it. This is a sequence. Here's the sequence. Yeah. Dot, 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 dot. That would be a sequence. It's just going to keep going. I could have that go forever and ever and ever. There's a pattern that's existing there. This is a sequence. Okay? What's the bottom one? You guys know that one, right? That's the months. January, February, March, April, May. If I change them up, it's not right. It's a different sequence completely, right? But those are sequences. This is times 5 plus 1, times 5 plus 1, times 5 plus 1. So there's a relationship that exists usually between the values in this, or these terms. Each one of these is referred to as a term. This is the first term, second term, third term, so on. This is the first term, second term, exactly. So we talk about terms. Terms is where's the position, because order matters. The position in the sequence is called its term. Okay? So let's get going here. So this is what you have on the bottom of your first page. We're going to start off with what an arithmetic sequence is. Arithmetic. Okay? Not arithmetic, arithmetic. So here we go. It's a sequence where the difference between consecutive terms is constant. And that consecutive term, that difference, is referred to as the common difference. Just plain and simple. So here I have values, okay? First term, second term, third term, fourth term. If I find the difference between consecutive, and you find difference by subtracting, the difference here is 8. The difference here is 8. The difference here is 8. So we call this the common difference. And the common difference, we use the letter D for that in this class. So D is the common difference. Common difference is D. Now, if I know the common difference, then I could find the next term. What would the next term in this sequence be? 31. And then it would be 39. Okay? Boom. Does it end? No, it doesn't. It will continue going because you can continue to add 8 over and over and over and over again. All right? So the first thing is, can you identify if a sequence is arithmetic or not? Does it have a common difference between consecutive terms? Good. Are those or not? So the next slide, I'm asking you, hey, are these 3 sets of sequences, are they arithmetic? And if they are, write down what the common difference is. That's all you're going to do. First step, identify if it's arithmetic or not. It's okay. A fresh mask. Feels good.
Why did you change that?
Because when I talk all the time, they just start to get a little bit more wet. This time of day it's like any different one. Oh, this one feels so good. Woo! I love Mondays.
It just depends.
Love them. Mondays are great. All right, the first one up there. Arithmetic or not?
Yes.
Yep, it is. Get the big old smile face. You betcha. Woohoo! Yes, it is. What's the common difference?
5.
5. Great. Okay. The second one. Arithmetic or not? No. It's not arithmetic. Nope. So if it's not, it doesn't have a common difference. Third one.
Yes.
Woo-hoo. Yep, it is. Common difference is
Negative.
-3. So what's the first thing I notice now? The common difference can be positive or
Negative.
negative. Either one. Positive or negative. All right. Okay. So now we've identified how to see if a sequence is arithmetic or not. All right. So let's just look at this bottom one down here. Okay. I'm just looking at the bottom sequence I have here. So if I asked you what the first term is, you would just say 17. If I told you, I said, hey, what's the third term?
11.
See, these are easy, right? What's the 79th term? Come on, what's the 79th term? You don't have it? Of course you don't have it right now. That's silly talk, right? Because I didn't write it down for you. Could we find it somehow? I hope. Would I have to write down all of my terms up to 79?
No.
Maybe. Maybe that's what you're going to do. I don't know. But there's probably a better way of doing that. And of course, that's what we want to be able to do. We want to be able to write the rule for the nth term of an arithmetic sequence. Okay? Now, there's two ways of doing that. Explicit and recursive. Okay? We're going to concentrate on only explicit. They're the easier ones to write. All right? So, in order to write the rule for the nth term of an arithmetic sequence, this is what you do. You write down a sub n, the nth term a sub n is equal to a sub 1, the first term, plus the quantity of n minus 1 times d, where d, of course, is the common difference. Okay? So in order to write the rule, I would like to have the first term and the common difference. If I have the first term and the common difference, I can write the rule like that. Oh. Do I have the first term? Yep, there's a sub 1. Do I have the common difference? Yep, the common difference d is -3. So I've got it. I can write my rule. This one right here would just be a sub n equals 17 plus n minus 1 times -3. Now, I could leave it like that. I know I could leave it like that. Okay? I also could simplify it if I wanted. And if I wanted to simplify this, of course, my first step would be to do a little distribution over here and get a sub n equals 17 minus 3n plus 3. And then I get a sub n equals -3n plus. That looks an awful like a what? That looks a lot like something. What does that resemble?
Quadratic.
Quadratic?
Looks like y.
Looks like what?
Y with an x plus b.
It looks like y equals mx plus b. Because it's kind of linear. But instead of calling it the slope or the rate of change, we call it the common difference. So this, when I simplify it, the common difference is the slope. Now this y-intercept isn't the first term necessarily, is it? It's the what term?
Zero.
The zeroth term, right? It's the zeroth term. It'd be when n is 0. Okay? Now, if this is linear, then that must also be linear. So when I simplify it, I see it as a slope-intercept form. What is that? is that? What form is that? Here, I'll help you. I'm going to help you a little bit. You ready? Here we go.
Point slope.
Does this kind of look alike?
What is that?
That's point slope
Oh.
form. Remember that form? Give you the point and the slope. You just plugged it in here. How many of you did point slope form in Algebra 1 class? I'm sure you did.
I just don't remember looking at it.
It looks like this, which can be rewritten like this. I just added y sub 1 to both sides, and then I changed the order due to property, right, of addition. And then that looks a lot like that.
You added one? Oh, it's on the, I can see it, okay.
Yeah, it's right here. And then I flipped it so it looked more like that. And I can put this M on the back side if I wanted. Now I want everyone to look at that. I want everyone to look at this. Notice up here that the a sub n would be like the what?
The Y.
The y. Okay? This x sub 1 is what?
X of 1 is B.
What is it when you use this formula up here? Which variables got replaced with numbers in this equation right here?
X1
x1,
and
y1, and
Y.
and m, right? You replaced these with values, right? M, of course, was the slope, which we know is the same as the common difference. But what about this x sub 1, y sub 1? What are those? Where are those up here? Well, this is the x sub 1. Guess what this is? This is the y sub 1. Okay? It's the y sub 1. All right. I want you to recognize, so here's the deal. Arithmetic sequences are a special type of linear function. So listen very carefully. Every arithmetic sequence is linear, but not every linear is arithmetic. I wonder why that is. Well, here's why. A linear function has a domain of all real numbers. By definition, an arithmetic sequence cannot have fractional values in its domain, because the domain values are the term positions, and the term positions are always going to be integers. First term, second term, third term. So it's a specialized linear function where the domain is 0 to infinity and it's the integers. Now, what do we call those values, 0 to infinity? But we're only talking about integers. What's that? They are real numbers, but -1's a real number, right? So what do we call the non-negative numbers that are integers? So there's whole numbers, there's counting numbers, they're all rational. They're not well, these aren't irrational.
What was the question again?
What do we call the values? Think of it like this. On the x-axis, 0 to infinity, and we're only talking about the integers. 1, 2, 3, 4.
Oh, the domain.
Well, yeah, that's the domain of an arithmetic sequence, correct. What do we call those numbers, though, in the number systems? All I'm asking you.
Numerical numbers? I don't know. I guess the ones I know.
Real numbers, and then you have what? There's all those subsets of real numbers.
Oh, the
There's what? Counting numbers. There's natural numbers. There's.
no,
Do you guys do this in Algebra 1? I don't even know.
I don't even think.
This is a long time ago.
Yeah.
This is a long time ago. Okay, you know what? I don't even care. What do I know? The domain is 0 to infinity, but we're only going to deal with integers, right? You're not going to have, in other words, hey, I want to know the 1.5 term. And what's that?
What's the
That was the
answer?
answer to the question.
I'll make you look it up at break.
Oh.
Okay.
You look it up at break.
You mean the numbers that have fractions in them?
No.
No, just like 1, 2, 3, 4, 5, 6, 7.
Yeah, they're just numbers.
They're numbers. They're a set of numbers. It's okay. Don't worry about it. Okay, got it. So anyways, right here, we need to be able to write a rule, okay, for an arithmetic sequence. And it's based upon this right here. It's based upon this. So guess what? Here's what we're going to do. We're going to try again, but a little different. This one's a little different. I didn't give you the whole sequence. I didn't. All I did this time was I gave you the common difference, and I gave you one of the terms. And I was a meanie. I didn't give you the first term. I gave you the 11th term. Now, here we go. Don't do anything. Stop. This is how we do the rule, right? I just wrote this down on the previous page. Here's the deal. Whatever term you put here, you look at this number, and that number has to be the same as that number. Because these are the input values. These are the domain values down here. Okay? So if I want to do this problem right here, I can use the 11th term. It's not a problem. It's just going to be this. A sub n equals the 11th term, negative 57, plus n minus what? Not 1. 11 times what? In this problem, negative 7. I'm not going to leave it like that. I'm going to simplify it. I'm going to simplify it. Okay? Guess what this is, by the way? That is the ordered pair 11 comma negative 57. That's the ordered pair. It's a point. Okay? Here it is. Let's simplify this. A sub n equals negative 57 plus, well, minus 7n plus 77. A sub n equals negative 7n plus 1. Got it. There it is. So the first term's what then? What is the first term? Bruh. Bill's Donuts. What's the, if I let n equal 1, what's the first term? A sub 1 is going to be negative 7 times 1 plus 20, which is what?
Negative
13.
Wait, oh, 13.
Oh my God.
Woo!
Just kidding.
Let's try a harder one. The second term. That'd be negative 7 times 2 plus 20.
Oh, wait, 6.
Thank
I'm
you.
not wait.
Okay, boom. So this now, if I have this, I can go and say, I can find any term I want, the value of those terms. All right. Okay. So again, this is nothing different than me giving you the slope and a pair of 1 point. That's all this is, guys. This is a point, x, y, input, output. I tell you 11th term, you give me the negative 57 back. Input, output, rate of change. It's just linear. Now, that means if I gave you 2 random terms, we should be able to write this as well. Now think about it, guys. We said this is really and truly nothing more than linear. This is an ordered pair. What ordered pair is this? 7 comma 26. And what ordered pair is this? If I wanted you to write the equation of a line through these 2 points, what's the first thing you'd do? Find the slope, rate of change, m. How do we do that? Change of y over change of x, right? So we do what? So when we're not going to call it m, it's called d, because we're talking about an arithmetic sequence. 71 minus 26 over 16 minus 7. Change in y over change of x. Rate of change, common difference. Here we go. Whoop, whoop. 45. Chapow. 16 minus 7. 9. Common difference. 5. Got it. Now I can go ahead and write my rule. A sub n equals, okay, I'm going to use this one right here. So what goes here? 26 plus n minus 7, beautiful, times 5. Abby decides she doesn't like that because she hates the number 7. Abby decides to use this one. So Abby's equation is going to look like this. A sub n equals 71 plus n minus 16 times 5. We want everyone to know that these are the exact same sequences. So we simplify them. So this one gives me a sub n equals 26 plus 5n minus 35. A sub n equals 5n minus what? 9. Over here, a sub n equals 71 plus 5n minus 80. A sub n equals 5n minus 9. They're the same. So it doesn't matter, okay, which ones I use. I can plug either one of them in. Either one I want in. Okay. Woo-hoo-hoo! I got a lot of energy today. Got a lot of sleep last night too. Not really. I was up at 4:30 this morning. What? It was up at 4:30. I was out the door at 5:15. I know.
You can come here that early?
Oh, no, I wasn't here.
Oh.
I could if I wanted. I could come at 3 a.m. and sleep here. Bring a cot? Sure. If I want, I have a key. I get in whenever I want.
Wasn't there a teacher that did that and they got in trouble?
Was sleeping here?
Yeah.
I used to sleep here.
Why? There was like a rumor or something in middle school that like some.
Rumor!
Okay.
Rumors!
Most likely was happening.
Rumors, okay. Anyways, any questions on any of these first slides we've done?
No.
We're good. Woo! Here we go. So, the first slide said we're talking about sequences and series. All right. So now we're going to talk about what an arithmetic series is. A series finds the sum of a finite or infinite number of the terms of an arithmetic sequence, adding them up. So I would add up all of the terms. If I add up so many of the terms, we call that a series, okay? Notice it says finite or infinite. There are actually infinite sums. Seems weird that you could add up an infinite number of things and get a sum, but you can. We're not doing that. We're going to concentrate on the finite here, okay? We're going to concentrate on the finite. That means you're going to have a set number of terms to add together. So here we are. To find the sum of the first n terms, okay? This is called the nth partial sum. Okay, nth partial sum, because you're only finding a sum of part of the terms in the sequence. And how do I know how many? It's the nth. So if I asked you to find the sum of the first 8 terms, it'd be called the 8th partial sum. All right? It says you can use the formula. There it is. Write that down. Okay, let me give it to you. So the formula is this. S sub n. So this S stands for the sum. The sum of the first n terms is equal to n, the number of terms you're going to add together, times the first term plus the last term divided by 2. Okay? Now in words, what does that mean? S of n is equal to the mean of the first and nth terms. That's this. That's the mean, because mean is an average. It's the average of the first and last term you're going to add up. Okay? And then you take that average and you multiply it by the number of terms you want to add together. Okay? That's what it is. That's what this is telling us to do. So let's try it. Let's try it. Here we go. I have given you a sequence, okay? Now, two things. First of all, A, we should be able to write the rule for the nth term. That should be easy. I don't need that to do the 8 partial sum, but we're going to do it anyways. And there's a reason for later on. Can somebody just help me out? What's the common difference on this sequence? 4. So D is 4. So the rule for the nth term is what? A sub n equals 5, first term, plus n minus 1 times 4, right? So A sub n, we can do this in our head. 4n plus 5 and a minus 4 is plus 1. There it is. Got it. Okay. You okay with that? All we do is found the rule. That's not the series. That's a rule for the nth term. Okay. I want to find this. This is called again the what? What partial sum is this? 8. This is the 8th partial sum. Okay. So what am I going to do? However I'm adding up goes here. So it's 8 times, it's the first term, 5, plus the 8th term, whatever the 8th term is. 1, 2, 3, 4, 5, 6, 7, 8. Oh, 33. Divided by 2. It's always divided by 2. I want the average of these. Equals 8 times, here I get 38 over 2, which is 8 times 19, which is 152. 152. Okay?
So that's the mean?
No. That's the sum
Okay.
of all of these. If I took these numbers up here and added these together, that's that. Okay? Now, let's do something here. You ready? What's 33 and 5?
38.
What's 9 and 29?
30.
30 what?
8.
8. What's 13 and 25?
38.
What's 17 and 21?
38.
How many 38s is that?
1, 2, 3.
1, 2, 3, 4. How many averages? How many of those averages? Like, what's the average of each of these? This is 38, 38, 38, 38. But if I took the average, what is it? 19. How many 19s are there? 8. Take a break. Take a break. Take a break.
Hurting my head.
By the way, if anybody knows of a car that's got damage on it that was at Bill's, let me know. I need some water. I need to hydrate. Oh my goodness. Babby, babby, bo, babby, phonema, phonema, bo, wabby, bee, ba, bo, babby,
That
babby.
reminds me of American Horror Story.
Why?
Because there's a series called Asylum, and the girl who like ran the asylum, they'd be in this room, and they'd have like this weird song playing in the background, but she'd come and do the name game.
No
They'd
way.
be like what was one of them? Like Hannah, Fana, Bofana.
Hannah, Bobana, Banana, Fana,
Yeah.
Fofana, Mima, Momana, Hannah. Yeah! Hamza, Bobamza, Banana, Fana, Fofamza, Mima, Momamza, Hamza. Pace yourself, Snyder. Got a long time to go.
Long time to go for what?
Till the day's over.
My English teacher keeps scaring me because we're reading Hamlet, we're doing these vlogs.
Love him.
She keeps thinking that, okay, I keep thinking that it's due every Monday over the weekend, but instead she'll like assign something else, but she'll forget to tell us that's what was due Monday, so all of us freaks out and tries to spark note everything, and then she's like, oh, you guys didn't only have till Tuesday. I was straight up with her last week though.
You were straight up with her?
I told her that I haven't done any of my homework since Friday. Like I told you how I just haven't done anything.
Yeah.
And she said I got lucky because everything wasn't due until the next day, so I woke up at 4 and did it all.
See, there's a big difference between English and math. I don't count homework.
Yeah, I know. But she doesn't really count homework. It's just we have an LP, you know what that is, learner's portfolio.
Uh-huh.
So we're supposed to have all of that like organized and stuff at the beginning of the year, but I didn't have a printer and I lost my list.
Mhm.
So I don't have everything in there. But she's been more lenient.
Yep. Are you guys wait, juniors don't do research papers. Is that senior year?
Seniors. Yeah, that's like a big part of their grade. But what was I gonna say?
I like Hamlet and egg omelets. Those are Hamlet and cheese omelets are good.
Everybody was ordering omelets last Thursday, and I don't know why.
Omelets are delicious.
Western omelets and
Oh.
build your own and sunshine skillets. That's all.
I love an omelet that has feta cheese, and broccoli in it,
mushrooms
and
bell peppers.
mushrooms. Oh, yum. Love that. Feta cheese in an omelet is amazing. Amazing.
My uncle, this might sound really weird, but he made me an egg white omelet one time.
Oh, yeah.
So he put cheese and bell peppers, but he put leftover corn in it from the night before.
Why not?
And it was so.
Well, you might as well. That'd be good.
And I don't like tomatoes unless it's in like
Salsa.
pasta, salsa. Yeah, I don't like fresh tomatoes.
Yeah, that's it. A lot of people are like that. They can eat ketchup, but forget there's certain things they like.
Yeah, I'll eat tomato soup and ketchup, all that. But
See? Shooby-dooby-wop-wop. It's a good day for giving a quiz. It's a good day for eating cheese whiz. It's a good day. Shut up, ba-ba-doo. Dooby-doo-boo-boo-dooby-wop. Do-do-do-do-do.
It is.
Sarah Daniels coming in the room. She must be absent today.
Are you older than your wife or are you younger?
I'm older by 19 days.
Oh, really?
Dang.
Yep. Isn't that amazing?
My mom is like almost 2 years older than me.
Your dad's a baby.
I know,
My mom and
right?
dad are like 4 years apart.
Who's older?
In age and in personality.
Whoa. Your mom's always been super mature.
Yeah.
I know, I can tell your dad's not mature. Not in a bad way. But
Oh, yeah.
He always acts like he's not mature.
He's not.
What does he teach?
Math.
Well, yeah.
Calculus. Calc 1, 2, Calc 3. And he also teaches a low-level resource room math with Mrs. Hauge.
Resource what?
Resource room math, which is like for students that have severe learning disabilities.
Fairmont Industries doesn't go to that, do they?
There might be some kids in there. I don't know. I doubt. I think most of them do their math in Fairmont Industries. But
Do they only have that one room for them?
Fairmont Industries, they're connected. Those rooms are.
Or the rooms all connected?
They have rooms connected there. All three. I think there's 3 rooms that are
Oh,
connected.
because I thought it was just that one room and I felt
You go to,
bad.
you know where Mr. McDonald is?
Yes.
The next 3 are all Fairmont Industries
Okay,
connected
because I've
together.
seen the one that has the Fairmont Industry plaque on it. I thought that was it.
Yes.
I was like, oh my gosh.
Yeah. The one that's furthest towards the quad, yeah, the door. I think that's like the actual classroom where they have desks all nice in a row, and then the other ones are more
Like
hands-on
scattered.
stuff.
Yeah, someone was telling me that you would have, like, people have opportunities to go and work with them.
Buddy system?
Huh?
Buddy system?
It might have been for middle school.
Oh, okay.
The 8th graders came, because
I don't
my brother was telling me about it. One of the kids in Fairmont Industries asked her to prom.
Oh,
And she couldn't go because she was an 8th grader.
Oh,
I was like,
how cute.
That's like really like, oh my god, this is when I was like in zone.
oh yeah, you know they're thinking about having a prom this year.
Like, literally asked for
It's up in the air right now.
It's all, yeah, they're starting to kind of try to figure out what to do, how to do it, who gets to go, who doesn't get to go.
I mean, honestly,
I think they're gonna look at grades.
Yeah, my
didn't wanna say
thinking on
no.
this is that if you're gonna open a school and
There was
already
like
have a fish
I looked at
and
Adam
one
with like
school
a high
of
five
kids,
or something.
and Trinarita, you can spread out more. I understand it's a dance, but I mean, we keep our mask on and not all classes. are 6
Here's the
feet
weird part. If you do it on school property, you have a lower percent of people you can put in a building than if it's not on school property.
apart. So are they thinking of moving it somewhere?
Yes, I think. That might be, they're talking about that. I don't know where, but that's the thing. Like, I think if it's in a school setting, it can only be 25% maybe of the threshold, like you could put in there. Whereas if you go to an outside venue, it's like 30%. What difference it makes, I don't know,
See,
but
I at least want to have a prom before I graduate. And if I don't,
Yeah.
I'm going to be very upset.
I told my advisory, we would just have an advisory prom.
Yeah, my mom and my dad said they'll throw one at our house.
Yeah, why not? You know?
So me and my friends had a fake homecoming this year, and I went to Macy's and got a dress for $12. But
There was probably a surplus.
and a pair of nude heels for $10. I'll show you a picture of it. It looks like a
You didn't wear Converse to your homecoming dance? Come on.
My Converse are brown right now. I have them since like 6th grade.
But those are a delight. And
Yeah.
you probably don't wear socks with them either.
I don't wear socks with these shoes.
Oh my goodness. Those Converse, don't ever bring them into this room then.
You want me to bring my work shoes into this room?
No, I don't.
Where is this at? Picture.
Wake up, Abby.
Where's the meagle? Bring him up.
Oh, it's on
Eagle's on
top.
top of the thing.
Huh?
He's observing the Meagle.
The Meagle, he's up there yet. She threw him up there.
Who's she?
What's her name?
Here's me and my cat.
Oh, at homecoming?
No, that was my FOCO dress.
Oh, it's photo.
Like fake homecoming.
Oh, you're fake.
Yeah, see, this is me and my friends.
No, that's a secret.
Oh, that's a cute picture.
I know, thank you.
If this falls over, Abby, you get
We have a
detention.
whole album.
If the ball hits the ground, it's a Saturday school also. So if it starts to fall, you better catch the ball.
He's gonna thing on it for us to do it.
Okay, let's get going here. We're ready. So let's go ahead and make sure we're okay with this. So what if I don't know if I think I didn't put a picture here. So we're gonna do that in a second. So I want to just extend this real fast. So I'm just gonna make up a problem here real fast. Okay, here we go. A sub n equals, I'm going to give you, in other words, the rule for the nth term. This, Okay, there it is. Got it? All right, I would like for you to find the following.
Oh, is this just a practice problem?
Yeah, it's a practice problem.
Oh my gosh.
Shabba-ba-ba-ba-doo. Do-do-do-do-do. Did you guys ever play the game hot cold? Like you had to walk around and say hotter, hotter, colder, colder, colder.
Yes.
I'm gonna do that with this. This is how she comes in.
My sister hides stuff in my room.
See if you could
No, actually,
You should hide it behind the Meagle
Do it.
box.
Do it.
I
behind
went
the
to my
TV.
room and she was like, I can tell her it's in your room. And you would never find them. And I was like, looking
Hey,
everywhere.
you should hide it behind the Meagle box.
For like a half an hour, I was looking. And she was like, and I was like, yes, you did. And I was like, I still couldn't find it. I found out like they were under the spin that happened.
I'm pretty sure the ball.
Oh no! It actually went through it. They don't make cans like they used to.
What are you gonna do with her coat now?
Oh, I don't do one. All right, who's got this?
I don't. Hold
You
on.
can still say hot or cold.
Who's got this? What do I need to find, by the way, on this?
The 10th term.
And did I give you the first term though?
Yeah.
Yeah, isn't the first term in that the rule? Yeah, it is.
Well, yeah.
Okay. So I really have given you the first term already. You have to find the 10th term in order to do this problem. Okay. All right. So it's going to be 10 times first term, -3, plus I need to know what the 10th term is.
I got it set -75.
So how do I find the 10th term? Put the 10 in here. 10 minus 1 is 9. 9 times -8 is -72, and a -3 is negative. Boom. There you go. All over 2. So that's going to be 10 times, what does this give me? -78 over 2,
30.
which is negative, right? Negative what?
-36.
Negative
38.
39.
39, that thing.
So my answer for this, of course, is what then?
-3.
It's -390. Yeah. There you go. Okay.
I did that a different way. Instead of plugging 10 into the A N or whatever,
Yeah.
I just did went back and did 10. I don't know how to explain it.
So did you use this formula?
I used the A to the N, yeah.
How did you get this -75 now I'm asking you?
Mhm.
Oh, did you simplify this?
I simplified because I went down to AN equals -8n plus 5 and then just plugged in.
Oh, that's fine if you simplified it.
Okay.
Yeah, you could. Okay, that's cool. All right, great. So arithmetic sequences and series, we're okay with those? Great, let's keep going. Here we go. Let's do this word problem real fast. So on this word problem, you're making a house of cards similar to the one shown. Okay? Write a rule for the number of cards in the nth row if the top row is 1. So this is row number 1. And row number 1 would be like your first term, in other words. Okay? So I have how many rows here? 3. So I have 3 terms, in other words. My first term is, how many cards are in the first row?
3.
3. How many are in the second row? 6. And of course, the third row is 9. Okay? So this is ace of 1. This is ace of 2. This was ace of 3. Okay, great. Now, so I need to write a rule. What's the common difference? D equals 3. That means that ace of n then equals 3 plus n minus 1 times 3, which means ace of n equals
3n.
3n. Boom. Okay, got it. That's part A. Part B says to find the total number of cards if the house of cards has 14 rows. So I'm finding then the sum of the first 14 rows. I'm finding the 14th partial sum. So here we go. Do that one. So what do I need to know? I got to find the 14th term at some point in time. So that's going to, let's go ahead and just fill this in. So it's going to be 14 times first term, 3. The 14th term is going to be 14 times 3, which is 42, all over 2. That's 14 times 45 over 2. Now I'm going to stop here for a second. Okay? If I'm doing this in my head, am I going to take 45 divided by 2? No. What am I going to do?
Simplify.
Huh? Yeah, how? I'm going to do this in my head. Can't you cross reduce? Did you guys ever do that?
Yes.
Because this is equivalent to this. They're the same.
What?
get rid of this circle. All right. This, what I have written here, is the same as this. Because in fractions, you do what? You multiply straight across, right?
Yeah.
1 times 2 is the same as 2 times 1. It doesn't matter where this part doesn't, if I'm going to multiply. So I can take 14 divided by 2 because it's an even. So I'm just going to do what? Instead of taking this and dividing by 2, multiplying by 14, I'm going to divide this by 2 and then multiply by 45. So it's 7 times 45, which is 315. I can do that in my head. You said you had no clue what I just did?
No, I don't remember the cross multiplying thing.
Not cross multiplying, cross reducing.
Yeah, but we would have just changed 14 to 2, 7, and 1.
Yeah, but you could have done.
Oh,
Right.
it's the same thing.
Yes! That's exactly what I did.
Oh, Jesus.
That's exactly what I did. It's okay. You're good. Okay. All right. So you will be doing word problems in here. And the series especially are word problems a lot of times. Abby, are you smushing your head together?
Oh, I'm sorry.
Oh, no, you're fine. I just want to make sure you're okay. You're doing this. I looked at the screamer picture, you know, that famous painting. All right, let's move on. Next step, geometric. Here we go, geometric. So we have to talk about these and what differentiates a geometric from an arithmetic. So a geometric sequence is, again, a sequence where the ratio, okay, different. Arithmetic was common difference, so I subtracted, okay? It's the ratio of 2 consecutive terms, and it will always be the same. It will be constant. So it doesn't have a common difference, it has a common or a constant ratio. The constant ratio can be called the common ratio, and we use the letter R to denote or write it down, okay? So let's look at these. I've got 2 sequences. If I just gave these sequences to you and said, hey, are they arithmetic? You would first start off by saying, are they arithmetic? Plus 4 plus 12, and not arithmetic. So now I'm going to see if it's geometric. What does that mean? It means that consecutive terms have a common ratio. You take a term divided by the previous term. 6 over 2, which is 3. 18 over 6, which is 3. 54 over 18, which is 3. So this is R. R is 3. There's a common ratio. Now, what does that common ratio mean? That common ratio is literally what you would multiply to go from term to term. 2 times 3, 6. 6 times 3, 18. 18 times 3, 54. So that common ratio is what you're going to multiply by to go from term to term. Okay. Second one over here. Again, you will never have an arithmetic that goes positive, negative, positive, negative. You can't be adding or subtracting the same thing over and over again and go back and forth between positive and negative values, okay? So is this geometric? I don't know. Let's see if it is or not. Negative 6 divided by 3 is? Negative 2. 12 divided by negative 6? Oh, look what that is. Negative 2. Negative 24 divided by 12? Yep, negative 2. So this one, R, is negative 2. So the common ratio could be positive, it could be negative. All right? It can be positive or it can be negative. Okay. Love it. Guess what? You've got 3. Are they geometric or not? If they are, please find the common ratio. go. Bring this down. Ah. There we go. Perfect. Okay. First one up here. Is the first one geometric? Yes, it is. This is a big old. Yes, it is. Yeah, it is. What's the common ratio on the first one? What's that? 1/3. Okay. 27 divided. So we're always taking a term divided by the previous term. So to go from here to here, you would multiply by a third times a third times a third times a third. Okay. Second one. What's that? No. No. It's not. Is it arithmetic?
No.
No, it's not. Okay. Last one. It is, right? Yep, R is -2. So now let's see what happened here. Now we also notice that the ratio doesn't have to be a whole number integer. It could be a fraction. So the ratio could be a fraction. It could be positive. It could be negative. Okay. Questions yet? Can I keep going? Can I keep on trucking along here? Okay. Hold on. Here we go. So now what's going to happen here? Okay, I know the next question. How would you write the rule to find the nth term of a known geometric sequence? Once I have the geometric sequence, how am I going to write the nth term for this? Well, there it is. Check it out. A sub n equals a sub 1 times r to the n minus 1. All right, let's just do this problem right here. Here, r is 15/3, which is 5. So the rule for this would simply be a sub n equals first term, 3, times 5 raised to the n minus 1. Done. No simplifying needed on that problem. Now, arithmetic was a special type of linear function. What does it look like geometric might be? Looks like it might be exponential. We'll answer that question in a second. We'll see if it really is exponential or not. Okay? Okay, so are we okay with this problem? Good. Good, good, good. This one's a little different. How's it different? Well, this time I gave you the common ratio, and I did not give you the first term. I gave you the 6th term, because I'm a meanie.
How dare you?
I'm a meanie. So I need to somehow write this out. Now, the rule we said for this was a sub n equals a sub 1 times r to the n minus 1. Just like on arithmetic, this idea, if this is the first term, this has to be the number 1. Okay? Now, actually, we're going to approach this problem a little bit different. This right here, a sub 6, is -96. What I'm going to do, let me go ahead and rewrite this down here below. Okay. I'm going to take this and put it, guess where? Right there. I don't know the first term. I have to find it. I know the common ratio on this one is what, though? 2. And I know that n, this -96 comes from when n is what? 6. So I'm literally going to plug these two values in for a sub n and n. So I get negative 96 equals a sub 1 times 2 to the 6 minus 1. Now I'm going to solve for the first term. Negative 96 equals. Okay, what do I get here? 2 to this is going to be 2 to the what? 2 to the fifth power. So a sub 1 is negative 96 divided by 2 to the fifth. That's negative 96 divided by 32, which is negative
Oh, wait, no.
negative 3. That's the what? First term. Now I can write my rule. So my rule is a sub n equals negative 3 times 2 to the n minus 1. Got it. Perfect. So this one was different. We actually substituted these two values in for a sub n and n. This is the a sub n value, and that's the n value you plug in. Okay. Keep moving. No questions. Me movie. Okay. So let's see. What's the next logical step? I don't give you the common ratio. I give you two random terms in a known geometric sequence. Two random terms. I've given you the second term and the fourth term. Okay? Now, there's a couple ways you could do this. Okay? Here's how I'm going to do it like this with you the first time. Right? So this is the first term, I don't know it. That's the second term. There's the third term. There's the fourth term. Right? Now, in order to do this, I have to find out what R is, right? That's what I don't know. And I said to you, R is what do you multiply a term by to get to the next term? Like from here to here, you have to multiply by R. And from here to here, you have to multiply by R. From here to here, you have to multiply by R. Hey, real quick. From here to here, you would multiply by what?
2R.
Not 2R.
R squared.
R squared. So guess what R squared equals? R squared is negative 3 divided by negative 12. Which is 1/4. Take the square root. Guess what R is? It's both positive and negative 1/2. I don't know which one it is. It could be either one. That means there are two possibilities for this one. Two. It could be positive 1/2 or it could be negative 1/2. Okay? So, let's keep going. I want a rule, I said. Okay, there's two possibilities for this. Possibility number 1 and possibility number 2. The first possibility, I'm going to have it be the positive 1/2 to the n minus 1. The second possibility, I'm going to have it be the negative 1/2 raised to the n minus 1. Okay? Now let's think about this. This is the number I need. To go this way, I would multiply by R. So if I wanted to go this direction, I should divide by R. Now I'm dividing by what? Which means you end up doing what? Multiplying by its reciprocal. So what are the possibilities for a sub 1? Well, if R, let's say R is 1/2, what would A be? Negative 24. If R was negative 1/2, I just put that in the wrong spot, didn't I?
Yes.
Sorry. Oop, there goes a pair. If r was negative 1/2, this would be positive 24. So notice what happens. The signs of the r value changed, and so did the initial values. They just switched. Positive, negative, switch it, positive and negative. They'll both work, and you have to account for both of them. Now, remember how I asked you, what does this look like? And you guys said it looks like it's what? Exponential. Okay, now remember, I said an arithmetic is a special type of linear. I stated that. Here's the deal. An exponential is not a special, a geometric is not a special exponential. And the reason it's not is, back in exponential, this value is never allowed to be negative. Remember what happened when it was negative? Instead of being growth or decay, it went back and forth because the output switched from positive to negative, positive to negative. And it oscillated, went back and forth. So geometric looks like it's exponential, but it is not exponential at all because the base, this value here, can be negative. And by definition in an exponential, it's not allowed to be negative. Okay? All right, well, you can kind of think of it like an exponential. It's kind of like one, but it's not one. Woo! Check that out. By the way, this is no different than what we just did on the test. This is the point 2, negative 12, and that's the point 4, negative 3. Remember what we did? You guys did a system of equations. Remember how you wrote two equations, substituted, you solved for A, plugged it in, solved, boom, bam, slam? You could do this the exact same way if you chose to. This one was nice, though, because usually if I'm doing this, I'm going to give you something like this when these are real close. Now, here's the deal. If I had made this an a to the second and this an a to the fifth, it wouldn't have been r squared. It would have been r what? Cubed. If this was a 5 and that was a 12, it'd be r to the 7th you'd be finding. Okay? I'm not doing that. Usually it's going to be real close. 2 or 3 apart is all I'm going to do. Next step, geometric series. Here we go. If we can have a geometric sequence, we better be able to have a geometric series. Add up the terms of a geometric sequence. Again, there can be both finite and infinite. We're going to deal with finite, okay, a set number. So we need a formula. Just like we did before, we want a formula. To find the sum of the first n terms of a geometric series with a common ratio that is not equal to 1. You use the following. Okay, so here it is. The sum of the first n terms is equal to the first term times the quantity of 1 minus r to the n over 1 minus r. Notice that that exponent n is only going with the r in the top. It's not the equality to the nth power, r to the nth power here. Okay? We're going to do this one. We're going to look at this problem right here and use this formula. It's not as bad as you might think it is. Okay? So, here I've given us a geometric sequence. It says find the sum of the first 6 terms. Okay? Now, in all actuality, I could, if I wanted to say 1, 2, 3, 4, 5, I could find the next term and then just add it in my head and probably just as fast. Probably would be. If I made you do a lot more, though, then it wouldn't be as fast. So we're going to use the formula just to try it. Okay? So again, I'm going to find the sum of the first 6, which is called the nth partial sum. Okay? That doesn't change. If it's arithmetic or geometric, it's the same. So this is the nth partial sum. So I said it's the first one, which is -1 times, here we go, 1 minus, okay, r is what on this problem? What is r? -2. So it's 1 minus, in parentheses, -2, and then -2 gets raised to the, which is what? 6th power. Over denominator 1 minus r. There we go. Okay. This is negative 1 times. Okay. In the numerator, what is negative 2 to the 6th power?
64.
64. So I get 1 minus 64 over, yep, 3, right? 1 plus 2 is 3. That's negative 1 times negative 63 over 3, which is negative 1 times negative 21. So what's the sum of the first 6 terms? Positive 21. Now that really is not that hard if you've got a nice small r value like 2. If r was 7, that'd be a lot more gross. Okay, that'd be a lot more gross. But it could be worse. It could be worse. Why, Mr. Snyder? Well, r could be a fraction. What if it would have been 1/2 instead? What if I flipped this and made it go negative 16 to 8 to negative 4 to 2 to negative 1? The r value then would be negative 1/2. And then this would be negative 1/2 to the 6th. It would be 1 minus 1 over 64 over 1 plus what? 1 over 2. You get fractions in fractions then. And you guys don't like fractions in general. Okay? So if it's fractional, it could be worse. Okay? But there's good news on the horizon. You just can't see the horizon yet. You'll see that tomorrow. Righty? Right now, I'm not going to give you one of these where that value of r is some nasty fraction. We'll do one like that together, and then I'm going to show you something you can do to avoid that in the future. Okay, we're almost done, guys. We got a word problem to go, and we're done then. Skydiving. Here we go. In a skydiving formation with R rings, each ring after the first has twice as many skydivers as the preceding ring. This formation here is for R equals 2. First thing, let A sub n be the number of skydivers in the nth ring. Find a rule for A sub n. Second thing, find the total number of skydivers if there are 4 rings. Okay, great. So here we go. So this right here, this first group here, that's A sub 1. What is A sub 1? 5. That's the first ring. This one out here is the second ring. This is A sub 2, which is what? 10. That's what this is telling us, okay? So I know my sequence starts off with 5, comma, 10, goes da, 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 da. So I know that the common ratio is ratio. Not difference, ratio. What do I do with these? I don't subtract them, I divide. What am I going to do here? R is 10 over 5. It's always a term divided by the previous term. So the common ratio is 2. Okay, great. So we can write our rule. A sub n equals first term times 2 to the n minus 1. There it is. Got it. Part B says to find the sum of what? 4 terms, 4 rings. Now I'm going to be honest with you. If I was given this problem, there's no way in the world I'd plug that into that formula. There's no way, because I have enough mental math to know that my numbers go 5, 10, 20, 40, and I can add those into my head in about 3 seconds. I know the answer to this is 75. Okay? I know that. Now we're going to use the formula just for the fun of it, because that's what they want us to do. We're just going to use the formula. If I use the formula, it would be what? What goes out here? 4 times 1 minus what? 2 to the 4th. All over 1 minus 2. This would be 4 times. What is 2 to the 4th? 16. So it's going to be 1 minus 16 over negative 1, which is 4 times negative 15 over negative 1, which is 4 times 15, which is 70. Or wait, not 70.
That's 60.
What's that?
Is that 60?
What's 60?
15 times 4.
Yes, it is. What am I doing wrong here? I just put that in wrong, didn't I?
Yeah.
wrong number. It was wrong. It was supposed to be five.
Oh, it's a 5. Duh. 5. Thank you. I just looked at this number and put it over there instead. Yeah, there we go. So it's 5 times 15, and that is my 75. I would say that it's a lot easier to just do what I did up there. But that's because it was only 4 rings. If I said, hey, they're going to set a world record, and they're going to have 20 rings, then maybe you'd plug it in here. I don't know. It'd be pretty gross. Because then you'd have 2 to the 20th power. So, arithmetic and geometric sequences and series. Know the difference between what a sequence is compared to what a series is. Sequence is just an arrangement where order matters. Series is the sum of the terms of a sequence. Okay? Now, on your paper, you already have this written. When I wrote it down, this assignment, when I wrote this, I got this thing all set up, and I wrote it down, I said, that's too many. So I went through and I crossed off a couple. So you can see it. I crossed off 14, I crossed off 24, I crossed off 32, 16, 40. Those are crossed off on yours. You do not have to do those. When you come in tomorrow, the first thing we'll do is put the answers to these up on the board. And then after that, we'll go ahead and do some extra problems. Okay? And we'll look at doing some word problems maybe together tomorrow as well. Okay. Woo! What time is this class in?
15.
See, 4 minutes left, roughly, and it's book work, so that's why I didn't make copies of it and put it online, because I knew you wouldn't have much time to work on it anyways. It's a beautiful day. And you guys know that the schedule for the remainder of the year is the same as it is, right? You guys heard that in the announcements?
Like we're not going back to
Yeah.
305?
The schedule is going to be like this the rest of the year. The Monday, Tuesday, Thursday, Friday, Wednesdays, virtual, and hour early dismissal every day. That's just the rest of the year is going to be like that. That's what he said this morning.
Thank God.
So there's no change in that.
Do you think next year we're going to go back to 5 days?
I would sure hope so.
What about the mask? Some people think we're not going to have to
You know, the mask part, that's going to be not our choice. That'll be more of a government choice, probably. The state will probably decide if we have to.
Next year, we will still be wearing masks.
Yeah, that's what
Yeah.
I'm thinking. But
I'm thinking we'll probably, at least for the beginning of the year, be wearing masks. But I think we'll be back full time next year, though. Also,
Yeah.
I don't think we'll be doing Wednesdays virtual and hour early dismissals. I think we'll be back.
Yeah, see, 'cause there's going to be juniors coming in next year for that program.
Oh my goodness, yeah.
And they want us to mentor them. But the only way that would work is if we were here on Wednesdays, if the schedule was still the same. Because that's the
Oh,
only day we'd be here at the same time. So like we'd be out there doing stuff while they're in the classroom, then we'd switch.
that wouldn't work very well, would it?
No, because they're the first 3 periods of the day, we're the last
Right.
5.
It's okay. It's okay.
There's, oh my gosh, there's so many people that applied.
For cosmetology,
Yeah, there's like over 100.
I got denied. I applied. I wanted to teach it. I was like, look, check this out. I can do this to myself. I can do anything.
We did, oh, I didn't show you this. We did cap highlights today.
Did what highlighting?
Oh, man.
We put a cap on our dolls and did highlights.
Ooh, that's looks like they got mold going on.
It's cholesterol.
Looks like mold.
That's what like bleach would look like.
Is that what, so that's to simulate?
Yes.
Gotcha.
So cholesterol, even though I think of cholesterol as fat,
Yeah.
it's a protein treatment for hair. So if you have like really brittle hair and thin hair, not thin hair, but you have really brittle like hair that's really coarse, if you do a protein treatment, it'll help rebuild your hair.
Gotcha. See, I didn't know that. So you're saying if I did that? I don't think so, Mr. Snyder. No, I didn't say that, Mr. Snyder. I'm sorry. That is not what I said at all.
Wrong translation.
How do you get back to the open door?
Bye, Yusef. Bye, Sarah. Have a great day.
Bye.
I'm thinking of this.
Have a great day.